Hello everyone, my name is Ainnur Rachmatunisa. I am one of exchange students in Department of Biology, and in this opportunity I would like to present my study about with the title Tyrosine Inhibitory Effect and Inhibitory Mechanism of Tiliroside and Peptide EF-5, and my advisor is Professor Dr. Chanpen Chanchao. As you can see in the picture, these are the products of skin lighten products that are used in the market. Beforehand, I would like to present the overview first, which include introduction, methodology and result, discussion, and conclusion. First of all, the background of this research is melanin are biosynthesized in the melanosomes of melanocytes, which are specialized cells situated in the basal layer of the skin epidermis. Once it matures, melanosomes are transferred from melanocytes to keratinocytes, and melanin have function like primary determinant of skin hair and eye color, defining important human phenotypic trait, has a critical role in photoprotection due to its ability to absorb ultraviolet radiation or UVR. And melanins biosynthesized called melanogenesis. Melanogenesis is a complex process with different stages. Melanogenesis begins with the formation of dopaquinone from L-tyrosine or L-dopa, like present in the picture. Two types of melanin are produced, which is eumelanins, which produce black or brown pigment, and pheomelanins, which produce yellow or reddish-brown pigment. In eumelanogenesis, dopaquinone undergoes cyclization and oxidation reaction to form dopachrome. 5,6-dihydroxyindole and 5,6-dihydroxyindole 2-carboxylic acid, or DHICA, are then generated and polymerized to give eumelanins. And during pheomelanogenesis, dopaquinone is attacked by the nucleophilic thiol group of glutathione, or cysteine, and leading it to the formation of 1,4-benzothiazinilalanine and polymerization of the monomeric units from pheomelanins. And what if the synthesis of melanin is disturbed? It may determine different types of pigmentation defects, which are classified as hypopigmentation and hyperpigmentation. From the melanogenesis, it has a tyrosinase as a key enzyme in melanin biosynthesis. Tyrosinase, also known as a polyphenol oxidase or PPO, is a multifunctional copper containing enzyme widely distributed in nature, including bacteria, fungi, higher plants, and animals. And tyrosinase is a glycoprotein that located in the melanosomal membrane. It is a copper-dependent enzyme that catalyzes the conversion of L-tyrosine into L-dopa, the rate-limiting stage in a melanin synthesis. And its function include monophenolase and diphenolase activity. It is involved in the biosynthesis of melanin and catalyzes the orthohydroxylation of tyrosine or monophenol to dihydroxyphenylalanine or dopa, O-diphenol, and the oxidation of dopa to dopaquinone or oquinone. This oquinone can then be transformed into melanin pigments through a series of enzymatic and non-enzymatic reactions. And why is it important to balance melanin content? Although melanin is crucial for protecting the skin, the abnormal or increased production and accumulation of melanin can lead into acute dermatological problems, include melasma, solar lentigo like in the picture, freckles, pigmented acne scars, and age spots. It can characterize a large number of skin diseases. Continuous UV irradiation can result in an increased risk of skin damage and cancer. Moreover, studies report that many melanogenesis disorders have been linked to the neurodegenerative disease, including Parkinson's, Alzheimer's, and Huntington's disease. And how can we balance the melanin? Apart from avoiding UV exposure, application of tyrosinase inhibitors may be the least invasive procedure for maintaining skin whiteness, and we can find a potential tyrosinase inhibitor. And this is the schematic illustration of the possible approach to interfere with melanogenesis pathway. Uh, Tyrosinase inhibitor is a process in that inhibit during melanin synthesis. And this is the classification of the pigmenting agents. Compounds have been divided and categorized on the basis of the report mechanisms of interference with melanin synthesis and deposition. In the box are tyrosinase inhibitors that were found before, including hydroquinone, arbutin, azelaic acid, kojic acid, resveratrol, and etc. But the tyrosinase inhibitors that were found before has side effects, like hydroquinone can cause exogenous ochronosis, arbutin can cause the contact dermatitis, like in the picture. Kojic acid also demonstrated carcinogenicity. And currently, several countries have officially banned the use of hydroquinone and kojic acid for skin treatments. Therefore, it is necessary to develop safe tyrosinase inhibitors. Safe tyrosinase inhibitors can be found in the nature uh, that were found before, like a flavonoid from the flavonoid compound. Flavonoid compound can be sourced from the raspberry. Raspberry, the fruit of Rubus chinyihu, has been used traditionally to treat prospermia and gonorrhea. From the raspberry, it can it results Tiliroside as the acylated flavonoid of Rubus species. Tiliroside possesses antioxidative, anti-inflammation, and antimicrobial activity, UV protectant, and cytotoxic activity against human leukemic cell lines. And reported before to show inhibitory effect on diphenolase activity of tyrosinase. From this research, the objectives are to investigate inhibitory effect on monophenolase activity by Tiliroside, which is extracellular tyrosinase activity, and to analyze inhibitory effect on tyrosinase and melanin reducing activities in B16 cells, which is included in intracellular tyrosinase activity. The hypotheses of this research are Tiliroside has inhibitory effect on both activities, diphenolase and monophenolase, and Tiliroside shows inhibition of intracellular tyrosinase activity and reducing melanin content on cell. The methodology in this research are first extraction and isolation of Tiliroside, and then extracellular tyrosinase activity assay, and then cell culture and cell viability assay. The fourth is intracellular tyrosinase activity assay, and then melanin content of melanocytes. The first is extraction and isolation of Tiliroside. Tiliroside was isolated from the ethanol extract of raspberry or Rubus chinyihu fruit. The raspberry extracted with 95% ethanol 3 times at room temperature. The ethanol extract was concentrated under reduced pressure. Then, the suspension of the extract in deionized water was liquid to liquid extracted by petroleum ether and acetic ether. The acetic ether phase was fractionated by silica gel column chromatography and elute, and it was purified by using Cevadex LH20 eluted with methanol twice and then recrystallized in methanol, and finally obtained a Tiliroside. The Tiliroside purity was no less than 98%. And the second method is extracellular tyrosinase activity assay. Compound, which is Tiliroside, substrate, which is tyrosine or L-DOPA plus PBS, and the tyrosinase was placed in 296 well plate and incubate within 20 minutes in 30 degrees Celsius. After all, the absorbance was measured at 490 nanometers. From the absorbance result can be found the inhibition type, inhibition constant or Ki, and activity of mushroom tyrosinase. Inhibition type can be assayed by the Lineweaver burg plot. Inhibition constant determined by the slope versus the concentration of the inhibitor. And activity of mushroom tyrosinase can be found with percent relative activity, which uh, which B per A multiply 100. A is OD in 490 nanometers in 20 minutes without Tiliroside, and B is OD with OD 490 meters in 20 minutes with Tiliroside. And from the extracellular tyrosinase activity assay, can be found that activity of mushroom tyrosinase in the graph that show 1, 2, 3, 4, 5, and 6 is different concentration of the Tiliroside. 1 is 0 millimolar, 2 is 0.021 millimolar, 3 is 0.042 millimolar, and the last 6 is 0.337 millimolars. The process curve for the inhibition of the monophenolase of mushroom tyrosinase by Tiliroside on tyrosine as a substrate was present in the graph in the picture. And the kinetic study of the enzyme is assayed by the plot of Lineweaver burg were shown in the picture. And the inhibition constant was 0.052 millimolars. It can be found by the slope versus the concentration of inhibitor. The concentration of inhibitors is 0 millimolar, 0.1 millimolar, 0.2 millimolar, 0.3 millimolar, and etc. Like I said in the slide before. And then from the extracellular tyrosinase activity for the diphenolase activity, it can same like before, assayed by Lineweaver burg plots for inhibition of Tiliroside on the oxidation of L-DOPA by mushroom tyrosinase. L-DOPA was a substrate, but in the slide before, it used tyrosine as a substrate, and the inhibition constant or Ki was 0.26 millimolar. The inhibition constant can we calculate by the slope versus the concentration of the inhibitor. And the next method is cell culture and cell viability assay. First, the P16 melanoma cells is cultured into 12 hours, and then the arbutin, Tiliroside, and 0.5% DMSO is added into B16 cells and incubated in 72 hours. And then add the aspirate media or entity solution and incubate within 2 hours. And then the DMSO is solubilization. After all, the absorbance is measured in 570 nanometers. And then this is the table that result from the absorbance. From the absorbance, it can found that cell survival or cell viability. MTT assay was performed to evaluate the cytotoxicity of Tiliroside on B16 cell. Cell viability test is to find a relative safe dosage for further intracellular determination of melanin formation in B16 cells. Tiliroside gave relatively lower cytotoxicity with cell viability about 80% in 0.168 millimolar, which had similar effects with arbutin at the same concentration. The next one is intracellular tyrosinase activity assay. First, P16 cells in 96 well plate is add arbutin, Tiliroside, and DMSO, and then wash with PBS with pH 6.8 twice and lysed with PBS containing 1% triton X100, and then shaken for 5 minutes, frozen at minus 20 degrees Celsius for 2 hours and disrupted by thawing at room temperature, and then add the L-DOPA as a substrate, and then incubate at 37 degrees Celsius for 2 hours. After that, absorbance is measured at 490 nanometers. From the absorbance result, we can calculate the percent inhibition, which is A min B divided A multiply 100. A is OD at 490 nanometers with 0.5% of DMSO medium, and B is OD at 490 nanometers with test samples. And from the percent inhibition, we can find in the result on the MTT test the concentration ranging from 0.011 until 0.168 millimolar of Tiliroside, and arbutin was used as a positive control. The results suggest that Tiliroside had inhibitory effect on intracellular tyrosinase activity and showed dose-dependent bioactivity, which was consistent with its extracellular tyrosinase activity. In contrast, arbutin at the same level of 0.168 millimolar showed lower inhibition. Then next, we can calculate the melanin content of melanocyte by this assay. In 96 well plate with the density of 1,000 cells per well is added by arbutin, Tiliroside, and DMSO, and then it cultured with 3 days and washed with PBS with pH 6.8 twice, and then add 100 microliters ethanol ethyl ether with 1 compare 1, and then kept at room temperature for 15 minutes, and then organic solvents were removed and cell pellets were dissolved in 150 microliters 1 molar and NaOH 10% DMSO solution 80 degrees Celsius for 3 hours, and then keep at 37 degrees Celsius overnight, and then the absorbance was measured at 450 nanometers. From the absorbance, we can found the melanin production inhibition. This is the melanin biogenesis in B16 cell result. The significant melanin reduction was shown at a concentration of 0.1 168 millimolar in treatment with Tiliroside, which is 54.1%. Meanwhile, the inhibition of the arbutin was 29.5 millimolar. For the discussion is lag period of monophenolase activity. Tyrosinase shows the monophenolase activity with a lag period. This period is the time that the enzyme requires to accumulate a quantity of O-diphenol in reaction medium and is proportional to the quantity of monophenol used. And when there was a lag period occurred simultaneously to the appearance of the stable product, which is a dopachrome as a characteristic of monophenolase activity. The lag period increased with increasing of concentration of Tiliroside. Like in the result in the slide before, the lag phase is lengthened longer in the concentration of 0.337 millimolar, and Tiliroside inhibit the monophenolase activity and lengthen the lag phase. With inhibitor structure similar to tyrosine structure, the inhibitory effect could be explained by the structural similarity between inhibitor and tyrosinase. Like in the picture, the first picture is Tiliroside, which has the same structure like the tyrosine. And Tiliroside and the amino acid tyrosine have a similar skeleton, which possibly explained the inhibitory effect of Tiliroside on monophenolase. And with what is the inhibitory mechanism? The type of inhibitory mechanism such as competitive, uncompetitive, mixed type, or competitive and uncompetitive, and non-competitive. A competitive inhibitor can bind to a free enzyme and prevent substrate binding to the enzyme active site. An uncompetitive inhibitor can bind only to the enzyme substrate complex. A mixed inhibitor can bind to both forms of free enzyme and enzyme substrate complex, and the non-competitive inhibitors bind to a free enzyme and enzyme substrate complex with the same equilibrium constant. In the picture, as action mechanism of reversible inhibitor, E is the enzyme as the substrate, I is inhibitor, and P is the product. ES is the enzyme substrate complex, and EI and ESI are the enzyme inhibitor and enzyme substrate inhibitor complex, which is the E plus S is the enzyme substrate complex, which is the competitive inhibitor, and the enzyme plus product is result from enzyme plus substrate, which is an uncompetitive inhibitor. And the Tiliroside was a competitive inhibitor because of the increasing concentration result in a family of line with common intercept on the 1 per v-axis, but with a different slope, like in the result before. And according to the competitive inhibition, Tiliroside inhibit the diphenolase activity of the tyrosinase by combining with the active site of the enzyme, and the presence of hydroxyl groups at position 5, 7, and the 4-oxo group in the Tiliroside molecule can chelate copper in tyrosinase. Tiliroside was found as derived from camphorol, proved to be a tyrosinase inhibitor, possessing the ability to chelate 1 copper in the binuclear activity center of tyrosinase. Camphorol inhibits the enzyme competitively, and the inhibition mechanism is a classical competitive type. Because of Tiliroside has the same like camphorol, it can it can result a same competitive inhibitor. And from the Tiliroside cytotoxic assay, it can be found that Tiliroside presented higher activity against melanin production than arbutin. Although the death of cells would lead to the reduction of melanin biogenesis, Tiliroside exhibits 14.5% inhibition of melanin biogenesis at 0.011 millimolar with little cytotoxicity on B16 cells. Thus can be concluded that Tiliroside, as a natural compound from raspberry, showed a monophenolized and diphenolized inhibitory activities of mushroom tyrosinase, and the inhibition mechanism of Tiliroside on monophenolized and diphenolized activity of mushroom tyrosinase was elucidated as a competitive type, and Tiliroside could significantly inhibit intracellular tyrosinase activity and melanin production with low cytotoxicity on B16 cells, in contrast to arbutin as a control. One natural tyrosinase inhibitor, and we can found another natural tyrosinase inhibitor in this research with EF-5 or ECGYF. ECGYF is a short sequence of peptides that is a natural pentapeptides from plants. It consists of a short sequence of the protein medicine found in Vigna plant, like in the picture. And why is peptide used to be a tyrosinase inhibitors? Because peptides containing the polar uncharged residue of cysteine are also good for tyrosinase inhibitor. And also, peptides from the Vigna plants is economically viable. The objective of this research are to investigate inhibitory effect of pentapeptide ECGYF or EF-5 and to analyze the toxicity of EF-5 to the cells. And the hypotheses of this research are EF-5 show inhibition activity greater than glutathione and arbutin, and also EF-5 is non-toxic to the melanocyte cells. The methodology of these results include tyrosinase activity inhibition assay, UV-Vis absorption spectra of tyrosinase, CD spectroscopy, and in vitro free radical scavenging assay, which use superoxide anion radical scavenging, and in vitro free radical scavenging assay use hydroxyl radical scavenging, MTT assay, and the intracellular tyrosinase activity inhibition assay. The first is tyrosinase activity inhibition assay. Beforehand, the peptide EF-5 was synthesized using the standard F-MOG solid phase synthesis method. Equal amount of tyrosinase was added to a phosphate buffer solution of PBS saturated with tyrosine 2.5 millimolar, to which solution of EF-5 at different concentration, like in the picture. And EF-5 at the different concentration were sequentially added. After incubation for 24 hours at 37 degrees Celsius, the visible light absorbance was measured at 475 nanometers using spectrophotometers. All measurements were repeated thrice, and the value of light absorbance of the corresponding group in the absence of tyrosinase was subtracted. And from the absorbance result, we can calculate the inhibition percentage, like in the equation in the picture. From that, we can find the inhibition percentage and the absorbance from the EF-5. The tyrosinase activity inhibition result is the picture In the picture, PBS solution saturated with tyrosine were mixed with different concentration of tyrosinase 1 kilonewton and EF-5. Show different inhibition from 0 millimolar until 6.2 millimolar. EF-5 is clear. That is indicating that EF-5 is able to inhibit tyrosinase significantly. If in the picture, when the EF-5 concentration is 0 millimolar, it showed the black color, which is it cannot inhibit the tyrosinase activity. And from the graph, the concentration of EF-5 had reached 6.2 millimolar. The activity of tyrosinase was inhibited almost completely, and it inhibited 50% at concentration of 0.46 millimolar. And the second assay is tyrosine activity inhibition assay, a comparison with the glutathione and arbutin. In the slide before is only from EF-5, but in this assay, tyrosine solution at EF-5, glutathione, and arbutin, and then incubate at 37 degrees Celsius for 10 minutes, and then add tyrosinase solution, and then the absorbance measured at 475 nanometers. From the absorbance value at 475 nanometers, it can be found inhibition percentage, and it can find the IC50 of the EF-5, glutathione, and arbutin. The result of comparison with glutathione and arbutin is IC50 of the arbutin, glutathione, and EF-5 were 5.73 millimolars, 1.18 millimolars, and 0.46 millimolars. That is indicate that the inhibition ability of EF-5 was much stronger than the others, because when the EF-5 at 0.46 millimolar can inhibit 50% of the tyrosinase. It's different from the arbutin that have to use 5.73 millimolars can inhibit 50%. And the UV-Vis absorption spectra of tyrosinase. The UV-Vis absorption is to determine the effects of EF-5 and glutathione on the structure of tyrosinase by the absorption spectra of tyrosinase in the presence of the compound. It can be mentioned like in the picture from the source, and then dispersion device, and the light is in the samples and detected by a detector. From the UV-Vis absorption spectra of tyrosinase, it results when EF-5 was added into a tyrosinase solution, the UV absorption peak was found to be redshift from 280 nanometers to 290 nanometers with the blue and navy lines, and the spectra of tyrosinase in the presence of EF-5 or glutathione should be consistent with the spectra of tyrosinase alone if no interaction was taken place between tyrosinase and EF-5 or glutathione. And then the CD spectroscopy is to study protein-to-protein interactions in the solutions. In this case, CD spectra were recorded in order to further study a change in the structure of tyrosinase in the presence of EF-5 or glutathione. These techniques are based on the differential absorption or emission of circularly polarized light. Thus, they suffer from intrinsic lower sensitivity than their counterparts not based on polarized radiation. In the CD spectroscopy performed at 293.15 K with a bandwidth and the step interval and scanning speed of 1 nanometers, 1.0 nanometers, 1 nanometers, and 50 nanometers minutes. From the CD spectroscopy, we can find the spectrum of the mixture of EF-5 and tyrosinase increased at 208, 218, and 226 nanometer. That is indicating an increase in the amount of alpha helix and beta turns. Contrarily, the spectrum of the mixture of tyrosinase and glutathione didn't show such change. And then for the in vitro free radical scavenging assay for superoxide anion radical scavenging is to determine the free radical scavenging ability of EF-5 by the auto-oxidation of pyrogalal. It can be measured by trace mixed with PBS solution of EF-5 or glutathione at different concentration and then add pyrogalal 50 millimolar or deionized water as a sample blank. And then incubation for 40 minutes in the trap at HCl 8 molar to stop reaction, and then absorbance was measured at 320 nanometers. From the absorbance, we can measure the scavenging effect percentage, and the superoxide anion scavenging rate was found. And the next for hydroxyl radical scavenging is to determine free radical scavenging ability of EF-5 or glutathione by hydroxy radical by the Fenton reaction. FeSO4 mixed with trace HCl and then add HTO2 1.5 millimolar or deionized water. And then 300 milliliter of EF-5 in PBS with different concentration. And then incubation for 30 minutes in a water bath for 37 degrees Celsius and absorbance measured at 510 nanometers. And then scavenging effect percentage was found. And we can find the hydroxyl radical scavenging rate percentage. From the in vitro free radical scavenging assay, we can indicate that they demonstrated similar reactive oxygen species scavenging ability. However, the ability of EF-5 to scavenge the hydroxyl radical was greater than the glutathione at low concentration. The figure is in the left. At high concentration, the rate of superoxide anion radical scavenging of EF-5 was greater than glutathione. And the next one is the cell viability was measured using MTT assay. MTT assay based on the conversion of MTT solution to formazan crystal by mitochondrial reductase. First of all, the A375 cells, melanoma cells, were seeded at a density of 10,000 cells per well in a 96 well plate. They were incubated for 24 hours at 37 degrees Celsius, and then it add arbutin, glutathione, and EF-5, and incubated within 24 hours. And then after the cell cultures were incubated with 20 ml MTT solution for 4 hours at 37 degrees Celsius. The culture supernatant was carefully removed from the well, and 550 ml DMSO was added, followed by shaking for 10 minutes to dissolve the formazan crystals. And the absorbance was measured at 492 nanometers using a microplate reader. From the absorbance, we can find the result of percentage cell viability. The percentage of cell viability It showed that the inhibitory effect of arbutin on the viability of melanoma cells was significant, while the glutathione and EF-5 was not. The EF-5 showed almost 100% cell viability. And then the next one is intracellular tyrosinase activity inhibition assay. The A375 cells in 96 well plate cultured for 12 hours, and then add for EF-5 arbutin and glutathione. Cultured for 60 hours, and then separated cells by using a 0.25% of trypsin ADDA solution and centrifuge, and then washed twice with PBS, and then added 0.5 mL NaOH and AOH 1 molar, and then cells were disrupted by sonication, and the cell incubation at 50 degrees Celsius for 10 minutes, and then the absorbance was measured at 475 nanometers. From the absorbance, we can find the percentage of total amount of the melanin. And the result for intracellular tyrosinase activity inhibition at concentration of 1 millimolar, the melanin inhibitory effects of arbutin and glutathione were similar, while that of EF-5 was twice compared to the other two. The total concentration of cells in the arbutin of 5 millimolar groups was much less than in the EF-5 0.5 millimolar group. It means that at the low concentration of EF-5 can reduce melanin higher than the arbutin. Therefore, the ability of EF-5 to inhibit tyrosine was likely to be better in the melanoma cells. For the discussion, intracellular tyrosinase activity using the IC50 of the arbutin as a reference, it was determined that the ability of EF-5 inhibit tyrosinase was also stronger than some anti-melanogenic peptides reported previously, which were obtained from the enzymatic hydrolysis of rice-bran proteins. EF-5 and glutathione contain the sulfohydryl group, which might significantly increase the lag phase of the catalytic reaction of the tyrosinase. For the UV-Vis and the CD spectroscopy results suggest that the EF-5 indeed binds to and interacts with tyrosinase and changes its conformation. Previous research have reported that the thiol group of glutathione chelates the copper ions in the active site of the tyrosinase and interacts with it. EF-5 doesn't interact with tyrosinase simply via the sulfohydryl of the cysteine residue as in glutathione. And for the radical scavenging effect, EF-5 contains the same sequence as a glutathione. The free radical scavenging ability of EF-5 might be same like the glutathione. When the tyrosinase inhibitor reduces the production of melanin, its reactive oxygen species scavenging ability should be compensated. Antioxidants play a synergistic inhibitory role in the tyrosinase inhibition. From the research can be concluded that pentapeptide EF-5, which is not only effective in inhibiting the tyrosinase activity but also possessing free radical scavenging ability. The IC50 of EF-5 was found to be about 1/12 and a quarter that of arbutin and glutathione. And the ability of EF-5 to inhibit tyrosinase is very remarkable tyrosinase inhibition ability with the highest cell viability. And the UV-Vis absorption spectra and CD spectra suggest that the EF-5 peptides might induce conformational change in tyrosinase and interact with it differently than the glutathione. The EF-5 may be used as a potential tyrosinase inhibitor in cosmetics or to treat skin disorders. And from the two research can conclude that the natural products such as Tiliroside and EF-5 preserve tyrosinase inhibitory activity, and both of the natural products are safe to the cells. And that's all for my presentation. For the last, thank you for your attention and the opportunity.